Have you ever driven through Spaghetti Junction in Atlanta to see where the roads cross and make connections? Maybe you've been a little further to drive across the Ravenel Bridge in Mount Pleasant. Or maybe you followed the Tigers to the West Coast when they won their third national championship and rode across the Golden Gate Bridge. Why are bridges important, and what makes them work? Bridges are important because they make connections between towns, cities, and neighborhoods that would otherwise be separated. For your challenge today, you are going to design and build your own bridge with household materials using the engineering design process. The first step in this process is to define the problem. People need bridges to cross bodies of water. Bridges solve a very common problem for mankind. There may be two major cities separated by a large river. If we need to send goods to the other side, we could go around the river or we could cross it by boat. To make transportation of people and goods faster, we build bridges. Today, your challenge is to design and build a bridge to connect two bodies of sand. You will mimic this by using two containers where you can pour sand, beans, or rice. These containers may be buckets, shoeboxes, or anything to serve as the two pieces of land. The two containers should be separated by about 12 inches in length. One of the most important goals of a bridge is to remain structurally sound while in use. Since this is not a bridge for people or cars to cross, the goal of this bridge is to be able to hold 200 grams in the midsection. The full restrictions for this challenge are listed on this slide. You can pause now to go over them. Now that we have defined the problem, let's take a look at some different kinds of bridges. Pause the video and work in teams to discuss the pros and cons of each type of bridge listed here. Did you discuss the differences between these types of bridges? Check out the descriptions below to learn more about each one. Now it's your turn. Take a minute to brainstorm your ideas for a bridge and create a plan. What kind will it be? What will serve as your supports? How will you attach the materials together? Once you have an idea, begin drawing your first model of your bridge. Let's get together some household items that you can use to build and test your own bridge. You will need two containers to serve as the land and a gap between them to serve as the water. Now gather materials to design and build a bridge that can hold 200 grams. We suggest using the materials listed here: 20 wooden sticks, 12 coffee stirrers, 1 meter of string, and 1 meter of masking tape. If these materials are not available, use what you have at home, such as popsicle sticks or straws, in place of the suggested materials. Pause the video while you take about 10 minutes to brainstorm and draw your design. For the weight measurement, you can use coins. Take a look at the table to see approximately how much each coin weighs. Now it's time to create your design. Pause the video while you take 20 minutes to build the bridge. Set a timer. Parents or facilitators allow students to do most of the hands-on work. This is a great time to develop their fine motor skills. Are you finished building your bridge? Great! Now let's figure out how it performs. Using the engineer's notebook, take a reading in millimeters for the clearance of your bridge. The clearance is the distance between the table and the lower part of your bridge deck. Record this value in the chart. Now start adding weight in 50-gram increments, or increments convenient to you, and record the new clearance accordingly until you reach 200 grams. If you reach 200 grams and your bridge meets all requirements, congratulations! You have completed the challenge. Now let's keep adding weight and recording the clearance of the bridge until it fails. Typically this happens when the bridge deck touches the container. Now that you have your data, let's calculate the deflection of the bridge. Deflection is the original clearance distance minus the newly measured distance. When you added your first 50 grams to your bridge, if your clearance was 145 millimeters and your original clearance was 150 millimeters, your deflection is 5 millimeters. Pause the video now to work on completing the table with the rest of the deflection measurements. Remember to use that brain of yours. Now let's use your data to graph the results. The independent variable is the load in grams. For the dependent variable, we calculated deflection in millimeters. Take a look at the table I created just as a reference for the graph. Here's the scatter plot I created with my results. First, label the horizontal axis where the mass or load in grams is plotted. Then label the vertical axis where deflection will be noted. Determine your scale on each axis, trying to use the whole grid. Pause the video and take a minute to plot your points on a graph. As you can see, the deflection increases as the load increases. This relationship between the independent and dependent variables is proportional. Does your graph show this type of relationship too? While these points do not form a straight line, we can draw a line of best fit through them. A line of best fit, or a trend line, is a straight line that best represents the data on a scatter plot. Here I have drawn a line of best fit through this data. Pause the video and find a line of best fit for your graph. To further describe our load and deflection, we can find the slope of this line. Remember, slope is the rise over the run, or the change in y values divided by the change in x values. For this line, the slope is found to be 32 over 500. We can interpret this number to say that for every 32 millimeters of deflection, the bridge has been loaded with 500 grams. Engineers use this kind of data to find where the maximum deflection will occur in a design, so that they can help reinforce or improve the design to make it better. Now that you have done all of this work, it's time to celebrate and showcase it. Create a video of you presenting your bridge. We would be happy to see this. Please tag us at Clemson Explore and show us what you've created. If you have time, try it out again. Want to keep improving your design? Go ahead and expand on the challenge. You can use other materials that are available in your household. Maybe you can create something big enough to hold a pet or relative. Thank you so much for participating in the Explore Mobile Lab program. We hope you learned a little about engineering and saw some meaning in your math work. Keep exploring!